Today we are going to discuss about FIR filter design by using of windows function. We already came to know there are different windows where we can use to design FIR filters. Here is a one example where we are going to use our rectangular window. Here is a problem is given for us. Problem is desired frequency response is given for us, that is HD of omega is equals to e raised to minus j omega tau for omega less than or equal to omega c, 0 for other values. Here length of the filter is given as 7 and cutoff frequency is given as 1 radians per sample. Okay, this is what the given problem. In this, what are the given? We have to write first. The given is a desired frequency response and length and also of a cutoff frequency they given for us. Next, to obtain desired frequency response in terms of time function, desired unit sample response, it can be taken by using the equation hd of n is equals to 1 by 2 pi limit changing from minus pi to plus pi hd of omega e raised to j omega n into d omega. Okay. Here they given what is the hd of omega. Here cutoff frequency is given, mention that in the equation where it is for 1 radians sample, means here taken as a mode, means both positive and negative values. For that reason it is going to vary from minus 1 to plus 1. Okay. Next, what is our hd of n equation? It is of already taken here, just substitute hd of n in the equation. So you will be getting as this equation, that is hd of n is equals to 1 by 2 pi limit varying from minus 1 to plus 1 e raised to minus j omega tau, this is what given for us, into e raised to j omega n into d omega. Next, again resolve this equation, take here from these terms as plus j omega. If I take j omega as common, I will be getting as from this n minus tau, that is what we wrote here, e raised to j omega n minus tau into d omega, we got the equation. Next, if I apply if I go for integration e power x, it is of e power x divided by x, that is e power x integration is going to be e power x divided by x only. So here we integrated the equation, integration is taken as 1 by 2 pi where limit is going to change from minus 1 to plus 5, e power is j omega n minus tau divided by j n minus tau. Okay, I mean e power to x integration, if it is there, means you will be getting as e power to x divided by 2. Here in this case x is a variable, here it is going to be variable is omega, that is d omega, for that reason. Okay. Same way here we taken the equation. After this we have to solve for this. When we are going to solve, before applying the limit, go for expansion of e power j theta, that is cos theta plus j sin theta. Okay, based on this function, first you go for the expansion, then apply the limit. If you apply that, you will be getting as sin n minus tau divided by pi into n minus tau, where you will be getting this condition when n is not going to be equals to tau. For when n is going to be equals to tau, what you have to do? So that what you have to do, substitute here in this equation n is equals to 2, tau means tau minus tau e power 0, e power 0 means 1, you will be getting here, I wrote already hd of n is equals to 1 by 2 pi, limit is varying from -1 to +1, e power 0 means 1 into d omega. So, you will be getting as, after simplification you will be getting 1 by pi here. Okay. Just wrote those two equations with the limits. Okay. You will be getting as hd of n is equals to sin n minus tau divided by pi n minus tau for n is not equals to tau. For n is equals to tau, you will be getting as 1 by pi. This is what the desired unit sample response. Okay. Next, we have to find what is the values of tau. Okay. To do that, we know our FIR filter is a symmetric. Okay. Based on this condition, here it is already taken. So, if it is of symmetric, we have to go for the condition. It is given h of n is equals to h of m minus 1 minus n. Okay. To do that, a small derivation is going here. We know that h of n is going to be taken as hd of n into omega n. hd of omega n, if it is going to be equals to, means this is also going to be equals to the desired frequency. Okay. For that reason, we wrote the equation as hd of n into omega n is equals to hd of m minus 1 minus n into omega n. Omega n cancel off, we will be left in with hd of n is equals to hd of m minus 1 minus n. Okay. This way the equation what we got. Next, substitute in from the previous, we got what is our hd of n. Just from his we got what is hd of n. In the same way, we have to go for hd of m minus n 1 minus n. Okay. Same, wherever n minus tau is there, just represent as m minus 1 minus n minus tau, here already written. Okay. Next, if sin terms again it cancels, I will be left with minus here. If we modify the equation, you will be getting as minus n minus tau is equals to minus m minus 1 minus n minus tau. Okay. If it is satisfying the condition, then we can tell that this is going to be satisfying. Okay. Next, if we simplify this equation, you will be getting tau value as m minus 1 by divided by 2. Okay. In this, we got the tau value. Substitute tau value in the equation. That is sin n minus tau instead of tau, m minus 1 by divided by 2. We have to write in the equation. Okay. Next, after getting this, next substitute here. They mentioned what is the m value. Okay. M is 7, so take that value as 7, substitute in the equation, in this m in equation. Okay, in this equation. So, we will be getting as hd of n is equals to sin n minus 3 divided by pi into n minus 3. Okay. For m minus 1 divided by 2 means 7 minus 1 divided by 2, 6 by 2 means n is not going to equal to 3, and for not equals to 3. Okay. This is what the equation we got. Next, we have to find what is the coefficient values for hd of n. For that, just take for different values of n from 0 to 6, because they asked for the length of 7. Okay. For that reason, when n is equals to 0, substitute in the equation here. Keep your calci when you are going to calculate in radians. Okay, not in degrees. Keep that in mind when you are going to calculate the calculation part for this. Okay. We will be getting for n is equals to 0 means 0.01497. Similarly, go on substituting for 1, 2, 3, 4, 5, 6. You will be getting the different values here. You have to note down of those. Next, we have to use our rectangular window. The rectangular window is given as omega n is going to be equals to be 1 for where n is varying from 0 to m minus 1 values. Okay, so here m minus 1 values means 7 minus 1 6 value, and to obtain h of n, we know that hd of n is going to be multiplied with the window function, that is in this case we are going to multiply with the rectangular window. Then h of n is nothing but our desired frequency response, that is hd of n. Okay, then multiplying omega n with the hd of n. Observe here, we got the values for hd of n here. These are all the values we got. It is in terms of hd of n. Next, we have to multiply with the omega n value. Okay, if we multiply hd of n and with the omega n value, we will be getting of what is h of n. Observe here, our hd of n is already taken and omega n value is 1. If I multiply 1 with any of the value, I will be getting the same value. For that reason, your coefficient values are going to be same as your hd of n. What I shown, the same values you will be getting here. Write those values as it is. We told our FIR filter is a symmetric. How it is going for? Just observe here. These two values, that is hd of 2 and hd of 4 are same. Okay, in the same way hd of 1 and hd of 5 are same. Then hd of 0 and hd of 6 are same. Based on this, we can tell that our FIR filter is a symmetric one. Okay, therefore that's what here we taken. H of n is going to be taken as h of m minus 1 minus n. M minus 1 is 6 minus n. This is what the equation here. Then if I substitute for n is equal to 0, h of 0 is equals to h of 6. When h is equals to 1, h of 1 is equals to h of 5. Then h of 2 is equals to h of 4. This is what a problem based on rectangular window function. Okay.